In this video, we're going to be solving quadratic equations by factoring. Now, in our first couple of examples, they've already factored it for us. But the first thing I wanted to do was write down a couple of steps. Number one, always make sure all of the terms are on the same side. So always have terms on the same side equal to 0. And in descending order. Oh, 2. Descending order. Now, we don't need that in the first couple of examples because they're already completely factored for us. And we know they did it right because they have a 0 on the right side. Or they're all set equal to 0. Now, on this first example, because it's already been completely factored for us, all we have to do is set each term equal to 0 and solve it like a smaller linear equation. Now, the equal sign in a little linear equation is really important. I can isolate the ends that I'm trying to solve for by moving the -2 over to the other side. The equal sign, though, is very powerful in that I can move the -2 over to the other side, but it changes the sign of the number. That 3n will be equal to +2. When the -2 crosses over the equal sign, it becomes positive. Now, in order to solve for n, I'm going to divide both sides by 3. On the left, we get the n all by itself, which is what we wanted. And on the right, we know the answer is 2/3. That's one of them. To solve the second one, we're going to start by moving the 1 over to the right-hand side. Over there, he will become a -1. So we have 4n equals -1. To solve for the n, I'll divide both sides by 4. So n is equal to -1/4. Let's look at number 3. It is also already completely factored for us. If you're comfortable and can look at it and say the answers are 1/5 and -1, you're welcome to do that on these. Otherwise, you're going to go ahead and set each one equal to 0. Each factor will be set equal to 0 and solved. We're going to move the -1 over to the other side first, so I have 5n is equal to 1. To get the n isolated, I'm going to divide off the 5, but if I do it to one side, I'll do it to the other. I end up with an n equals 1/5. On our second factor, to get the n isolated, I'm going to move the 1 over to the right-hand side, which will make it a -1. Here is number 5. Excuse me. I'm going to start by looking at it and say, well, they're not all on the same side. This 33k needs to be brought back over. So I'm going to end up with 3k squared. When I move the 33k over to the other side, I'm going to want it second so that my trinomial is in descending order. That 33k, though, will be a -33k. And the +72 is already there. So there's step 1, to move everything over to the same side set equal to 0 and in descending order. Now, I look at the 3, 33, and 72, and I happen to notice that they all have an extra 3 in common. So I factor it out. It is a greatest common factor. So when I factor the 3 out of the first term, it's going to leave behind a k squared. When I factor the 3 out of the second term, it's going to leave behind a -11k. And when I factor it out of the fourth term, it's going to leave behind a +24. Now here's where my factoring strategy comes into play. I have factored out the greatest common factor. I'm still left with a type 1 trinomial. Type 1 because it's got a 1 out in front. That means it factors into two-term phrases immediately. I'm going to take this constant term and bring it out. Find the factorings for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I need to make them add up to -11. I'm looking at the 8 and 3. I can make that add up to -11 by making the 3 and the 8 both negative. Now, factors of k squared will be k and k, and the factors of 24 that I'm going to use are going to be -3 and negative 8. Don't forget, the 3 was part of the original problem. He's part of the final factoring. Now to solve, I'm going to set each piece equal to 0. Even that first term. You will have single factors sometimes. Now, this one makes a lie. Because he's false, he's not part of the answer. We get to drop him. K minus 3 equals 0. I'm going to move the negative 3 over to the other side, so I'm going to end up with K equals 3. For the second factor, I'm going to move the negative 8 over to the other side. That's going to make it K equals positive 8. Let's look at number 7. On number 7, again, it's not in the right order. I need everything on one side and set equal to 0. The 7v squared is fine where he's at. This negative 35v, though, I need to bring over to the other side. And I need him next. That negative 35v, though, will turn into a positive 35v when it crosses the equal sign. And then minus 42. Now, I happen to look at it. It's not a type 1, or is it? Well, the 7, 35, and 42 all have a factor of 7 in common. So I'm going to factor out the 7 in the entire trinomial. It's going to leave behind a v squared, a plus 5v, and a minus 6. It is a type 1 trinomial, which means I'm going to be able to build the two factors immediately. I'm going to take 6, or the negative 6, and write his factors down. 1 and 6, and 2 and 3. On this one, we're going to have to be really careful. In class, I mentioned that 6 is a tricky number, kind of evil. When I'm looking to see what I'm going to have to build, I need to build a positive 5. I can do that with both factors, negative 1 and positive 6, or positive 2 and positive 3. Both of those make 5v, but I need them to also multiply out to be negative 6. So we're going to have to go with this pair. So we have factors of v squared are v and v. I'm going to use the negative 1 and the positive 6 and bring down the 7. He was part of the original problem, so he's part of the final factoring. Now set each factor equal to 0. And again, on the exam, you don't have to write all this out if you can do some of it in your head. This is for someone that does need it. 7 equals 0. That's a lie. V minus 1. I can solve for v by moving the 1 over to the other side. I get a v of 1. In this last factor, I can move the 6 over to the right. That's going to give me a v of negative 6. And real quick, one more before we go on to our second video. I'm going to start by moving everything back over to the left. I got stuff everywhere. I'm going to move the negative 3v squared over to the left. That's going to make it a positive 3v squared. I'm going to move the 6v also over to the left. It's going to make it a negative 6v. So now everything is equal to 0. But I've got to clean it up a little bit. I'm going to combine the like terms. These two go together, and these two go together. 3v squared and minus 2v squared is 1v squared. Negative v and negative 6v makes negative 7v, and the 12 is okay. That is actually a type 1 trinomial, so I'm going to open up my 2 parentheses factors. The factors of our constant term 12 are going to be 1 and 12, 2 and 6, and 3 and 4. I need factors that will help me build a negative 7v. Definitely the 3 and 4. I'll make them both negative, and that's how they add up to negative 7v. Now, factors of v squared are v and v, and I know that factors that multiply out to be 12 that add up to negative 7 are negative 3 and negative 4. I'll see you in the next video.